Okay, class, let's review zeros of a polynomial function and the multiplicity of those zeros. We have this definition up here on top. I've got this number r in red, and it is going to be called a zero of f of x if you plug r in as input into the function and you get an output or a y value equal to 0. Okay? Now, notice that that gives you an ordered pair. So this gives us an x-intercept. And that x-intercept would then be the point r, 0. Okay? So the r is your input or your domain value, and the y is 0. Okay, that is your output range value. Okay, now when you have a graph of a polynomial, at that x-intercept, we can have different possibilities here. At that intercept, highlight that in red for you, the graph could certainly be positive, right? So if I'm positive, then that means that I'm above the x-axis. So remember, when you're above the x-axis on a coordinate system, you'd be in quadrants 1 or 2, right? So the graph could be positive, and then it could be decreasing. So you've got a bunch of positive y values, and then boom, it hits the x-axis. And the function now takes on a y value of what? 0, right? And then it crosses through, and then the function now has negative y values. So that means that your graph could now be in quadrants what? 3 or 4, right? So this is what we call crossing. Crossing the x-axis. Okay? But it could also be the case that the function is negative, so it's down below, and then it's increasing, okay? It's negative, it's increasing, and then boom, hits the x-axis, and the function takes on a y value of 0, and then it crosses through, and now the function is positive. So we have sign changes, okay? Then there is the other possibility where the graph here at the intercept, the function could be positive, right? And then it's again decreasing. But then it hits the x-axis and it does not change signs. It will then touch and turn around. So that means that, excuse me, the function is going to be positive, takes on a y value of 0, and then it stays positive. Okay? Or we could have the function starting below the x-axis. So it's increasing, you've got negative numbers, and then boom, it takes on a y value of 0, it touches and turns, and then it stays negative. Okay? So this is what I'm going to call touching and turning. Touches and turns. All right. Now, whether or not the graph crosses through the x-axis or it touches and turns at the x-axis is going to depend on the multiplicity of that 0. Okay, so that's what I want to talk about now. To start, let's look at an example. Let's say I have this function f of x, which is x cubed times x plus 1, and then that's multiplied with x minus 3 to the third power. Okay. Now, if I wanted to find the zeros, I would have to set my function equal to 0. And then you would have to set each of those factors to 0, right? So you've got x cubed equals 0, or x plus 1 is 0, or x minus 3 squared is equal to 0. Okay? Now, you notice that there's a x to the third power, which really means that there are 3 factors of x. And that would then lead to x equaling 0, and really there are 3 solutions, okay, because of those 3 different factors. So instead of writing it out 3 times, I could now say that that x, which I'll now write it in red, that 0 now has a multiplicity, we call it, multiplicity of 3. And that's because that 0 in red was a solution to this equation 3 times. And it's all because of that factor, that power of 3. Okay? Now, this x plus 1 equals 0. If I solve for x, I get -1 is a 0. Okay, so that -1 in red is exactly like this number r in red. Okay, if I were to plug in -1 into my function, I would get an output of 0. Okay, and it is a solution to this equation, but because there's only one factor of x plus 1, we would now say that that 0 of -1 has a multiplicity of 1. Okay? And then lastly, that x minus 3 quantity squared, there are 2 factors of it. And then you've got x equals 3, x equals 3, but there are 2 factors of it. So that 3 in red has a multiplicity of 2. Okay? And it's because that x minus 3 was a factor twice. Okay? And therefore that 3 was a solution to this equation twice. Okay, so how does that affect the graph? Well, let's write it out. Statement A. If our R in red has an odd multiplicity, then, as it turns out, then the graph of our function f of x will cross the x-axis at the intercept r0. Okay? And if r, which is our 0, has an even multiplicity, then the graph of f will, do you remember what the other situation was? That's right, it will touch and turn at the intercept r0. Okay? So let's use the information that we have here for this function. Okay, so what I'm going to do right now is I'm going to make a sketch of that function f of x. Okay? All right, now this would be a third-degree polynomial. I'm sorry, what am I talking about? Not third degree. This is going to be a, let's count, a 6th-degree polynomial, because you've got a x cubed, which is really multiplying with that x, and if you FOILed out x minus 3 to the 2nd power, that would give you x squared plus some lower degree terms. So then you would have an x squared, okay, plus some lower degree terms, and so this would then give you x to the 4th, and then times that x squared, blah blah blah, and then that would be your leading term. Okay, so applying the leading coefficient test, or what I prefer to call it the leading term test, I know that this function is going to rise on the right and it's going to rise on the left. Okay? Now, you have 0, -1, and 3. And so those three red numbers are going to produce intercepts. One here at -1, -1, 0, another one at 0, 0, and then another one here at 3, 0. Okay? So, using what we wrote, that x equals 0 has a multiplicity of 3. And 3 is an odd number. So where do we have odd? Oh, right here. So that means that our graph is going to cross the x-axis at that point 0, 0. Okay, so here we're going to be crossing. That -1, that 0 has a multiplicity of 1, which is also odd. And so we're going to be crossing, okay, crossing, crossing. And then lastly, at 3, 0, that has an even multiplicity of 2. And so we see that when it's got an even multiplicity, the function will be touching and turning. Okay? So here at 3, 0, we're going to be touching and turning. Okay? So here goes our sketch. We already know that we're rising to the right, which means that the function has to be positive and it's above the x-axis. So it now has to go and hit that intercept, but at 3, 0, it's going to touch and turn. So it bounces off. Okay, so it hits and it bounces off. Then it's going to be positive, and then it's got to come back to this intercept, which is at 0, 0, and we're going to cross through. So positive to negative, and then it has to come back, and then at -1, 0, it's going to cross through. So here we have negative y values, and then we have to cross through and then go up to the rest of the graph, because we know that we are rising to the left. Okay? So there's your sketch of the function f of x. All right?